Hi, I am just checking in to make sure that this activity, the bake sale problem, makes sense. I'm not going to do the whole thing, but yeah, here we go. Okay, so it says the student council is planning a bake sale to raise money for a local food pantry. They are going to be making apple and peach pies. They have decided to make 10 pies. Each pie requires 2 pounds of fruit, therefore, they need a total of 20 pounds of fruit. Okay, so I'm just highlighting that to help us remember. Then it says in the table below, fill out the first 2 columns only with 8 possible combinations that will yield 20 pounds of fruit. So what I did here, these are the combinations of pounds of fruit that we came up with in class. I think I did the first one and then different students came up and did other ones. Or maybe they just told me because it all looks like my handwriting, but it doesn't matter. And we know that all of these are right because all of those are pairs of numbers that add up to 20. So all of these are combinations that give us 20 pounds of fruit. Part B. 1 pound of apples costs $2 and 1 pound of peaches costs $1. Fill out the rest of the table above to determine how much the student council will spend for each of the combinations. Apples are $2 a pound. Okay. So apples are $2 per pound. And peaches are $1 per pound. So then the cost, if I bought 11 pounds of apples, that's going to be 11 times 2, which is $22. And then this is going to be 9 times 1, which is $9. And then I just go through and do those calculations. These numbers are pretty friendly, so hopefully you can do them in your head, but there's lots of calculations. So if you'd like to grab a calculator, you're welcome to do that. 10 times 2 is 20. 8 times 2 is 16. 10, 4, 14, 2, 48, 12, 36. These are just times 1, so 10. These are all dollars. So then the total cost, 22 plus 9 is 31. This is 30. This is 28. That's 25. 22. 14 and 3 is 27. 2 and 19 is 21. Okay. All right. Okay. We did that. So then in part C, Ms. Harper, the student council advisor, tells the students they have exactly $28 to spend on fruit. How many pounds of each type of fruit should they buy? So they have the required 20 pounds of fruit and spend exactly $28. All right, so we can look in our table. The way we set up our table, every combination is the right number of pounds of fruit. So all we need to do is find the right one that has the right total cost. If you look here, $28. That has 20 pounds of fruit because 8 pounds of apples and 12 pounds of peaches is 20 pounds of fruit, and it costs the right amount. So we can do 8 pounds of peaches. And, oops, that is not correct. We can do 8 pounds of apples. Oops, draw. And 12 pounds of peaches. Which is this combination right here. Okay. So the reason this is a system of, what a system of equations is, it's 2 equations that are happening at the same time. So there's two equations. The first equation, I need 20 pounds of fruit. And in the second equation, I need it to cost exactly $28. So because I can do an equation for the 20 pounds of fruit, and I can do an equation for the $28. And so a system is these two both need to happen at the same time. Okay. All right, so let's take a look at this. What's going on? Here we go. Part D, if P represents the number of pounds of peaches purchased and A represents the number of pounds of apples purchased, the situation above can be modeled by the following equations. P plus A equals 20. This is the one where pounds of peaches plus pounds of apples is 20 total pounds. So that's my equation that tells me I need 20 pounds of fruit. And then the second equation, 2A plus P is 28. $2. Well, it's really the 2A is the cost of the apples, right? Because each pound of apple costs $2. So the 2A is the cost of the apples. So the cost of the apples plus the cost of the peaches. Remember, that's 1P because it's $1 per pound of peaches. Is 28 total. And does my solution make both equations true? Yes, it does. And we'll show this 8A equals 8, P equals 12. This was my solution. So with this first one, I'm going to call this first one A plus P equals 20. A is 8 plus P is 12. That equals 20. That really does equal 20. So yes. And then the second equation, 2A plus P equals 28. So 2 times 8 plus, oops, I don't know what just happened there. Plus 12 equals 28. So 16 plus 12 really does equal 28. Okay. Graph the equations from part D on the coordinate plane below. Label the lines according to the graph they represent in context. I've already graphed these equations a couple times, so I know what the graphs are going to look like. If I hadn't done that, I would probably do this. I would use the intercept strategy. So if I know that P plus A is 20, and I find the X and Y intercepts, so when Y, oh, hold on. Let's try this again. What is going on? Okay. If I go P plus 0 equals 20, then P has to be 20. If I go 0 plus A is 20, A also has to be 20. So when I graph that, it's going to go through those 2 points, and I use my straight line tool. It's not a perfectly straight line, but that's what I did. Okay. And then for the other one was 2A plus P equals 28. I'm going to use the same strategy. And if A is 0, 2 times 0 plus P is 28. P has to be 28. And if I go 2 times A plus 0 is 28, 2A is 28, so A has to be 14. All right, so when peaches is 0, apples is 14, which is right here. And when apples is 0, peaches is 28, which is right here. And I don't know if my straight line tool is going to do what I want, so we're going to see. Yeah, it doesn't like to go between. Okay. All right, let's do a little rise over run here so we know what our, gosh, I'm sorry. So that goes up by 14, and that goes down by 28. 14 over negative 28 is negative a half. Okay, so it's going to go like this. And my pink line is going like this. And you might notice that this point right here where the two lines cross, that point right there is a special point. It's called the point of intersection. Which is just a fancy way of saying that's the point where the two lines cross. And this line is P plus A is 20. And this line is two A plus P is 28. And when both of those are true at the same time, you get the point of intersection. This point of intersection is the point 12, comma 8, because it's 12 and 8, which is the solution to the system. Oh, I just did part G. Find the point of intersection in the graph above. What do you notice? The point of intersection is 12, comma 8. And this is the solution. Because the 12 is on the peaches line, so it's 12 pounds of peaches. And the 8 is on the apples line, so it's 8 pounds of apples. So that point of intersection is the solution, which makes sense because it's the one perfect combination that makes both of those constraints true at the same time. Yeah, okay, that's enough to get you started. I hope you found this helpful, and come to office hours if you have questions. Okay, bye.